2001 number 2. We're looking at some problems today that have tables. This is a common type of problem to see on free response, where you're given data on a table and you have to do some approximating. In this case, we're going to do some approximating with the table, and then we're given some functions, or a function, to find more exact values. Part 2, or problem number 2, says the temperature in degrees Celsius of the water in a pond is differentiable function W of time t. So we've got degrees Celsius and time in days. The table above shows the water temperature is recorded every 3 days over a 15-day period. Part A asks us to use the data from the table to find an approximation for the derivative of W of 12. All right, show the computations that lead you to your answer. So big thing here, it says indicate units of measure. Right there, if it tells you to indicate units of measure, pretty much guaranteed that's going to be worth 1 point. So even if you can't answer the question, put down a number, and if you know what the units of measure are, you can get a point. What are the units of measure going to be here? We're talking about the rate of change of W when t equals 12, right? The derivative of W at 12. W is measured in degrees Celsius, t is measured in days. So what would our units be? Can you hear the crickets? All right. Rate of change. Derivative is what? Just in general, not looking at this question, what is the derivative? Come on, it's only one of the biggest things we've talked about all year. Slope of the tangent line, right? Slope, it's a rate of change. We're looking at the rate of change of this function at a specific time. Well, look at the two things that we're comparing here. It's degrees Celsius and days. So our rate of change is going to be in degrees Celsius per day. Right? It's the slope. Y, change in y over change in x. So this is like our y value. This is like our x value. So the units, that right there is worth a point. So even if you don't know how to do the rest, put a value with that, you're going to get 1 point. But again, we're trying to approximate this slope. All right, so we know it's a slope. It's a rate of change. Well, there's actually 3 different answers that they'll accept for this approximation. If we want to find the slope at 12, what we can do is we can find the slope between these 2 points, 9 and 12, or we can find the slope between these 2 points, 12 and 15, or the slope between 9 and 15. So there's 3 different options. So if we did between t equals 9 and t equals 12, we're just finding the slope between those 2 points. So we do the change in y, 22 minus 24, over the change in x, 12 minus 9. That would give us negative 2/3 degrees Celsius per day. Or we could do this between t equals 12 and t equals 15. That would give us an approximation of a slope near what it's going to be instantaneously at t equals 12. So here we're going to do these 2 points. We're at 21 minus 22 over 15 minus 12. We get negative 1/3 degrees Celsius per day. And our last option is between t equals 9 and t equals 15. So we'd have 21 minus 24 over 15 minus 9. So negative 3 over 6, or negative 1/2 degrees Celsius per day. Now, this last one that we did, that's our average rate of change, right? Average rate of change from t equals 9 to 15. That's the average rate of change over the course of those 6 days. from 9 to 12, it's the average rate of change from 9 to 12. 12 to 15, average rate of change over those periods of time. So any one of these three answers would give us 2 points. 1 point for the actual value, 1 point for the actual label, like indicating the units of measure.